Good morning to all of you. In this class, we are going to discuss about representation or expression of gradient, divergence, curl, and Laplacian operator in spherical polar coordinate system, that is your SPCS shortly written by using OCCS, that means orthogonal curvilinear coordinate system. In our last class, we have been discussed representations or expression of these operators in Cartesian coordinate system by using OCCS. Before that, we have been discussed what is the importance of OCCS. So I suggest to all of you that before you have to watch today's video, at least you go through the video in which I have been discussed the importance of OCCS. Okay, I will give the link in the description of today's video. Okay, so let's start our today's discussion. Now, here let us consider Pxyz be any point in orthogonal curvilinear coordinate system where three unknown curves such as u, v, and w intersects with each other as shown in figure. Not intersects. Okay, you write, no problem. Intersects with each other. Okay. So this is the point P where the three curves intersects. So already we have been discussed in that video. That means the previous when we discussed the importance of OCCS. At that time we discussed that one curve like this, the azimuthal curve, and one polar curve, and the so-called line. This is the line or the radial line is the three curves intersect at this point. Here you can see in this polar coordinate system, spherical polar coordinate system, if I will be change this phi, that means this is the so-called circle by changing this azimuthal angle. Then if the point will move like this on the surface of the sphere, then it will change this angle theta. So another surface like this, that is your another surface, and another surface is the straight line which is passed through this point, starts from the origin. Detailedly we have been discussing in that video. So here we can consider the u is the radial component, the u surface is the radial component, that is your r, and v is your polar angle changes the surface correspond to change of polar angle. That means this surface is belongs to V, and another one is your changes of azimuthal angle W corresponds to phi in spherical polar coordinate system. So in OCCS, UVW converted to R theta phi in spherical polar coordinate system. So here three curves in OCCS intersects with each other, and we found the point P, and the corresponds surfaces in spherical polar coordinates are r, theta, and phi. These r, theta, phi curves are intersects with each other at this point P, and we found this point P. Okay, due to the intersection of this r curve, which is a line, and another this one is the change of azimuthal angle curve, and this curve. Detailedly we have been discussed. So these three curves meets together or intersects together at point P, and unit vectors are normal with each other. So hence SPCS also called as the orthogonal curvilinear coordinate system. Okay, so same thing it is written here. Now we are going to go for the figure. So here this is a point in spherical polar coordinate system. So if I will draw the perpendicular to the xy plane, let this is your q, and again perpendicular qt, again perpendicular qs on y axis, and this sq or ot is your x component, os or tq is your y component, and this one is your z component, and this is your r, that is your radial component or distance from origin to this point, having the angle theta with the z axis, and this is the angle phi with x axis. Now if we are consider the triangle OPR, OP and R. So this is the perpendicular on the Z axis. Okay, clearly you have to draw this figure. So you no need to draw these curves because these things already we have been discussed in that video. In that video means the video where in which I discussed about the importance of OCCS. Uh, given the link, I given the link in this video. You can go through that video thoroughly. Okay, so but you have to draw this figure clearly. So from this triangle OPR, cos theta is nothing but OR. This is the base. Sorry, OR by OP. Okay. So carefully you have to watch. This is the 90 degree angle, and this is the theta. So this is the base, and this will be the diagonal of this right angle triangle OP and R. So for this OPR, cos theta will be this one, OR by OP. OR by OP. OR is nothing but OP cos theta. Here OP is nothing but R. So R cos theta. Let this is your equation number 1, and collectively these are considered as equation number 1. This is your equation number 2. Now we have to consider sin theta for this triangle. Sin theta means here PR by OP. PR by OP. So here PR will be how much? OP sin theta. OP is nothing but R. So R sin theta. Let this is your equation number 3. Now consider OTQ. O here O, T and Q. If I am going to consider OTQ triangle, you can see that cos phi. See, this is the right angle triangle, this is the phi, so this is obviously the base. So cos theta will be OT by OQ, OT by OQ. So OT is nothing but x component, x by OQ. So x by OQ. Here OQ is nothing but R sin theta. Why it is? See, PR or RP. RP is nothing but, here we found R sin theta, right? PR or RP we found R sin theta. You just write it here. I not written. Your OP is nothing but how much? R sin theta. But see, this having the same length in this rectangle. In this rectangle PROQ rectangle, PR equal to OQ. So obviously PR if sin theta, OQ will be R sin theta. Okay, if PR R sin theta, OQ also R sin theta. So here we have to substitute OQ as R sin theta by equation number 3. By equation number 3. Okay, so that implies x will be how much? R sin theta into cos phi, R sin theta into cos phi. Let this is your equation number 4. Now we are going to go for sin phi. Sin phi. Sin phi means QT by OQ. QT by OQ, right? So obviously QT will be OQ into sin phi. So TQ by OQ. TQ by OQ is the sin phi for this triangle. So that implies sin phi will be TQ is nothing but what? Y. Here you can see OS is nothing but TQ. If this is Y, this also Y, right? So Y by OQ. OQ we found how much? R sin theta. So Y by R sin theta. So that implies Y will be R sin theta sin phi. So here X component and Y component in the spherical polar coordinate system, we found that here R sin theta cos phi X component and Y component we found R sin theta sin phi. Let this is your equation number 5. So obviously we know that if we are going to consider the sphere, then x square plus y square plus z square equal to r square. And if I am going to consider x value, y value, z value, whatever we previously found, this one, z value, x value and y value, if I am going to substitute over here, I will get r square. and r is nothing but root over this one. Cos theta is this one, theta this one. See, OR by OP, if I am going to consider this triangle, cos theta equal to OR by OP, and OR is nothing but Z, OP is nothing but R. Here R is nothing but x square plus y square plus z square root over, and theta in this way we can found. Phi we can found from the triangle OQT by considering tan phi equal to QT by OT. So QT equal to y, QTY, and OT is your x. So y by x. So phi will be tan inverse y by x. Okay. So as we discussed previously, that for the spherical polar coordinate system, u is considered as r, v, theta, w, phi. Hence corresponding unit vectors will be written as, see, previously for OCCS, u was e1 cap, v e2 cap, w e3 cap. So for this case, spherical polar coordinate system, as u transform to r, v transform to theta, and w transform to w phi, then corresponding unit vectors will be er cap, e theta cap, e phi cap. Instead e1, e2, e3, er, e theta cap, and e phi cap. So it is well known that to find the gradient divergence core Laplacian in spherical polar coordinate system SPCS from OCCS, it is essential to find out H1, H2, H3 in SPCS. Okay, so this kind of work already we have been done when in our last class, because H1, H2, H3 is very much important, which will be found by using expressions of OCCS. So in OCCS, H1 is nothing but del x by del u square, del y by del u square, del z by del u square. Already we have been discussed. Now here for spherical polar coordinate system, x value is how much? That we have to substitute. Y value is how much? R sin theta, R sin phi. X value is your R sin theta cos phi. Z value R cos theta. That we have to substitute over here, here, and here. And del u is nothing but R. Del R, because u is transformed to R. So here del of x component is your R sin theta cos phi. Y component R sin theta sin phi. Del by del R of R sin theta sin phi. Del by del R of R cos theta. Whole square, whole square, whole square, whole root over. Okay, so here you can see this term is going to be differentiated with respect to r. So we can found sin theta cos phi. So here it is square means sin square theta cos square phi. Here del r by del r of r sin theta sin phi differentiated means we found sin theta sin phi. We can square is there, so sin square theta into sin square phi, and here it will be cos theta means cos square theta whole root over. Here you can see that this entire value will be 1. How it is? Here you can see that if I will take common here sin square theta from these two terms, then we can found cos square phi plus sin square phi itself 1, sin square theta plus cos square theta 1, root over of 1 will be 1. Okay, just wait, I am going to show you. So here I am going to take the common sin square theta from these two terms. So sin square theta, so this will be cos square phi plus sin square phi plus cos square theta is there. Cos square theta is there. So this value is 1. Sin square theta plus cos square theta will be 1. Root over of 1 will be 1. We found H1 equal to 1. Then we are going to go for the H2. In OCCS H2 we know that value is what? Del x by del v square, del y by del v square, and del z by del v square. That we know, a root over. Here v was there. So but in spherical polar coordinate system, v is transformed to theta. So instead of v, what we have to write? Theta. So del x by del theta, del y by del theta, del z by del theta, square, 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 and whole root over. Now we have to put the value of x, y, z over here. X value r cos theta cos phi, r sin theta sin phi. Y value r cos theta is your z value. This term is going to differentiate with theta. We can found this is sin theta. So cos theta, cos phi is there, r is there, square. Del by del theta of this one, sin theta is there. So this will be cos theta. So r cos theta sin phi whole square, and this is your cos theta is there. Differentiated with respect to theta will be minus sin theta. So it will be minus r sin theta whole square, whole root over. Okay. Now here you can see this will be r square cos square theta cos square phi. This will be r square cos square theta sin square phi. This is your square is there means r square sin square theta. So from these two terms we can take common r square cos square theta. We can find cos square phi sin square phi. Here r square sin square theta is there. Sin square r square sin square theta is there, right? So this value is 1. Then r square cos square theta plus r square sin square theta, taken r square as common, so cos square theta plus sin square theta will be 1. Root over of r square will be r. So h2 value we found r. Likewise h3 in OCCS, you just recall in OCCS case, orthogonal curvilinear coordinate system, h3 is nothing but del x by del w, del y by del w square, del z by del w square. So but in case of spherical polar coordinate system, w is transformed to phi, right? So instead of w, what we have to write? Phi. So here del x by del phi, del y by del phi square, del z by del phi square, whole root over. We have to substitute the value of x, y and z over here, here and here. That means this term is going to differentiate with phi. This term is going to differentiate with phi, and this term is going to differentiate with phi. So here you can see here cos phi is there. So differentiation with phi means sin phi. So r sin theta sin phi. Here sin phi is there. Cos phi it will be cos phi. So this term not contains any phi term. So del phi del by del phi of this term will be 0. So root over of whole root over. So here you can see r square sin square theta sin square phi, r square sin square theta cos square phi. R square sin square theta taken common, so it will be sin square phi plus cos square phi. This is your 1. Root over whole root over means r sin theta. So h3 we got r sin theta, and h2 we got 1, and h1 is your 1. So now we are going to use these values to find out the gradient, divergence, curl and Laplacian in spherical polar coordinate system. First we have to go for the gradient in spherical polar coordinate system. To find out gradient in spherical polar coordinate system, first consider gradient in orthogonal coordinate system. That means in generalized coordinate system. We found that del phi. So here I consider del f. I am going to show you. Wait. You can check your note previously. Whenever we have been discussed gradient in term of orthogonal coordinate system, we found that del phi, that means gradient of a scalar function is this one. At that time scalar function is taken as phi, symbol phi. But here we consider f, small f, because here you can see that w is converted to phi. So here one symbol is represent the angle. So if I will consider phi is the scalar function, then at the time of writing it will be create the confusion. Okay, so only for that here we consider instead of phi another scalar function f, but the expressions are same. Instead of phi we consider small f. Okay, so here del phi is nothing but 1 by h1, this one 1 by h2, del by del v phi 1 by h3, del by del w phi e3 cap. So instead of phi we consider f. Let this is your equation number 7 for this discussion. And as we have been discussed just now in this content, that h1 we found also h1 1, h2 r, h3 value is your r sin theta, and u whatever spherical polar coordinate system it is converted to r curve, v converted to theta curve, w converted to phi curve in your spherical polar coordinate system, and corresponding unit vectors are these are e1 will be called as er cap, e2 e theta cap, e3 will be e phi cap, corresponds to phi, theta and r. So now we have to just substitute these values in your equation number 7. So here 1 by h1, h1 value is 1, so this will be 1, del by del u, del by del u means del by del r of phi, e1 cap means er cap. Okay, next term 1 by h2, h2 is r, so 1 by r del by del theta, because v is your theta, so del by del theta of f, and e2 cap is nothing but e theta cap. Okay, next 1 by h3, here h3 is nothing but r sin theta, so 1 by r sin theta, del by del w is nothing but phi, so del by del phi of f, e phi cap. So this is the required expression of gradient in your spherical polar coordinate system. Now we are going to go for the divergence in spherical polar coordinate system. So to find divergence in SPCS, first to consider divergence OCCS. In case of OCCS, divergence of a vector field is nothing but this one, 1 by h1 h2 h3 del by del u of h2 h3 a1, del by del v of h3 h1 a2, del by del w of h1 h2 a3. Let this is your equation number 8. Now we have to put the values of h1 h2 h3 here and u v w in SPCS in equation number 8. What we can get, see here 1 by h1 h2 h3, that means multiply of these three will be r square, r into r sin theta will be 1 by r square sin theta. Here del by del u instead of u we have to write r, del by del r, h2 h3 means r square sin theta a1, then del by del v is theta, so it will be del by del theta h3 h1 is 1, h3 is your what, r sin theta, right, r sin theta, right, so it will be what, r sin theta a2, and here del by del w means is your phi, del by del phi, and h1 h2 it is 1 r, it will be r only, right, so del by del phi of r a3. So now I am going to multiply this term with this. Here you can see this is your del by del r. Okay, so sin theta will be constant taken outside, so sin theta got cancelled. We found 1 by r square del by del r of r square a1, right. So here you can see that this is del by del theta of r sin theta, so here r is constant, so when it will be multiplied with 1 by r square sin theta, so r can be taken outside, cancelled with 1 r, so it will be 1 by r sin theta, 1 by r sin theta, 1 by r sin theta, because 1 r is cancelled with this one. Okay, so 1 by r sin theta del by del theta of sin theta a2. Now again 1 by r square sin theta multiplied with this term will be this one, because here r is constant, because it is del by del phi of this one, so r taken outside, cancelled with this one, we found 1 by r sin theta del by del phi of a3. This is required expression of divergence of a vector function in SPCS. See here I written AUVW means originally it is in orthogonal curvilinear coordinate system, transformed to SPS, and we found the divergence. So here u is nothing but is your r, theta and phi. Okay, so here also f in general I written, but this expression is only for the SPCS, so here f is a function of r, theta, phi instead of u, v, w, right. So I suggest that you have to write this one, don't write this one, you write this one, and here also you write a is the function of r, theta, phi. Okay, now we are going to go for the curl in SPCS. See to find curl in SPCS, first we have to consider curl in OCCS. So we know that curl of a vector in SPCS, here A is the function of u, v and w. Okay, is nothing but curl of a vector function in OCCS is nothing but 1 by h1 h2 h3 h1 e1 cap h2 e2 cap h3 e3 cap in matrix format. Okay, del by del u, del by del v, del by del w, a1 h1 h2 a1 h2 a3 h3. Now we have to substitute the values of h1 h2 h3 e1 cap e2 cap e3 cap and u v w here in this equation number 9. So already we found the values, these values. So here we have to substitute only h1 h2 h3. h1 is 1, this is r sin theta, and e1 cap is nothing but er cap, and h1 is 1. h2 is r, e2 cap is nothing but e theta cap, h3 is your r sin theta, e3 cap is nothing but e phi cap. Now del by del u v w are nothing but r theta phi. So here a1 h1 is your 1, so only a1. a2 h2 is nothing but r a2, h3 h3 is nothing but r sin theta a3, right? So inside the matrix, and here h1 h2 h3 is nothing but r square sin theta, because h1 is 1, this is your r, h3 is your r sin theta, so obviously r square sin theta. So this is 9a, equation 9a. This is the required expression of curl of a vector function in SPCS. So if I am going to represent this matrix format in another way, here this one, that means 1 by r square sin theta is here. Each and every term I have been evaluated. Here you can see that er cap, del by del theta of this one minus del by del phi of this one, r sin theta a3 minus del by del phi of r a2 er cap minus r e theta cap. So here minus r e theta cap, and this del by del r of r sin theta a3 minus del by del phi of a1. Then this term plus r sin theta e phi cap, this like this. Okay, del by del r of r a2 minus del by del theta of a2. So this is 9a and 9b, both are the required expression of curl in SPCS. Now we are going to go for the Laplacian in SPCS, spherical polar coordinate system. So similarly we written over here that to find Laplacian in SPCS, first consider Laplacian OCCS. See, in the note I written step by step. You write the note in this way, this format, and in the exam you can skip the steps. Okay, so we know that Laplacian in OCCS is nothing but this one, del square f. Here I consider f. Maybe you have to remember, I am going to show you. At the time of discussion of OCCS, we found the Laplacian is this one, del square phi. At that time we considered the scalar function is phi, and this one del phi by del w. But in spherical polar coordinate system we faced one problem, that w is nothing but phi, so del phi by del phi is creating the problem. Only for that, to avoid that problem, we instead of phi we consider here f, small f. Okay, so same we have been written. See, del square phi, here del square f, 1 by h1 h2 h3, 1 by h1 h2 h3, del by del u of h2 h3 by h1, h3 by h1. Here del phi by del u was there, so instead of phi we written del f by del u. And the second term is your del by del v of h2 h3 by h1, del by del v of v, this is v of f, plus del by del w of h1 h2 by h3, del by del w of f. This is your equation number 10. Now we are going to substitute these values in this equation number 10. What we are going to get? h1 h2 h3, h1 into h2 into h3 is nothing but r square sin theta. Here del by u is nothing but r. Here r we have to substitute, v is theta, here phi we have to substitute. instead of v we have to put theta theta, w in, we have to put phi phi. So here del by del u, del by del r, here h2 h3 is nothing but r square sin theta, h1 is 1, so divided by 1 1. So del phi by del u, del phi by del r plus del by del theta, here h3 h1 will be sin theta divided by h2. See, h3 your r sin theta divided by r, h2 is your r, so only we can found r. So del by del v, del by del theta of f, plus del by del w, del by del phi. Here h1 h2, h1 is 1, h2 is your r, divided by r sin theta, because h3 your what, how much, h3 is your r sin theta. Okay, so now we have to substitute. We found 1 by sin theta, del by del phi of f, del by del phi of f, right? So here you can see that I'm going to multiply 1 by r sin theta with each term. Okay, so here del by del r is there, so sin theta is constant, so taken outside, cancelled with this term, only 1 by r square will be there. 1 by r square, del by del r, del by del r, r square, del by del r of f. Okay, next here del by del theta of sin theta. Okay, so it could not be taken outside, so simply this term is going to be multiplied with this term, 1 by r square sin theta, del by del theta of sin theta, del phi by del theta, right? Okay, now here del by del phi of 1 by sin theta, here sin theta is constant because it is the derivative with respect to phi, so 1 by sin theta taken outside, it will be 1 by r square is there, sin theta will be multiplied with this, means 1 by r square sin square theta, del square, here del by del phi is there, so here del square f by del phi square. So this is the required expression of Laplacian of scalar function f. Here you have to write not u v w, this is r theta phi. Okay, because we are considering SPCS coordinate system, so instead of you just write this one, f scalar function f, function of r theta phi in SPCS. Okay, so here we have to stop our discussion. In our next class we are going to discuss these operators, how uh, expression of these operators in cylindrical coordinate system. Thank you so much for watching this video. Write down the note perfectly and ready for the next class. Okay, thank you.